Welcome to our first session of the third season of AYA Power. We're going to give it a few seconds here as some more people are filing in, and we will get started. Just thank you all for being here on a Friday. Wow, it is Friday. Friday, October 17th. Here we are. All right. So for those that don't know me, I am Nick Yalrakis, Executive Director and co-founder of Elephants&tea. I am delighted to be Kayla Fulgenetti today, who is usually the host of these. Kayla is attending ACCC this week, and so I'm filling in for her for our first session for this season, and we're super excited about that. Before we get into the theme and a few other things for the season, we changed some things up from a technical nature. We're doing Zoom meeting, as you all are probably realizing coming in, and your cameras might be on, so feel free to turn them off right now if you'd like to. But this way for Q&A, please put your comments and questions in the chat. We'll keep an eye on that. Mike and Scott will go ahead and lead that Q&A with Brandon at the end here. But definitely feel free to drop comments in the chat there, and we'll bring down the spotlight so everyone can see who's asking those questions when it comes time for that. For those that are not familiar with our website, I want to drop that in here, our AYA Power site with all of our previous recordings and sessions all on there. So we're delighted to have a really cool library and in-depth library of resources and recordings at this point. Again, for those that do not know what the acronym POWER stands for, and that is the Adolescent and Young Adult Program for Oncology, Workforce, Education, and Resources. We have a theme this season, something a little bit different from what we've done in years past. Our theme this year is moving forward with purpose. With this season comes at a time when oncology providers are navigating growing complexity, limited resources, and widening gaps in care. This season invites participants to reflect on the challenges facing AYA cancer care today and to be part of shaping what comes next. Together with guidance from experts like Brandon across disciplines, we'll explore how to move forward as a community committed to progress, equity, and better outcomes for AYAs. And today's first session is the changing of epidemiology of AYA cancer in the US with Brandon Hayes-Lattin. And I also want to really quickly thank our two sponsors for helping us fund AYA Power across the board. I'm Not Done Yet Foundation is our founding sponsor, and AZI Pharmaceuticals is our supporting sponsor. So thank you to both those organizations for making this possible. I will hold off on talking about our next session when we get to the end, but that's going to be on November 5th. For now, I will pass it over to my friend Mike Roth, who will introduce Brandon.
Thank you so much, Nick, and thanks to everyone for joining today and joining us for the third session or the third season of Power, Session 1. We are really lucky that Dr. Hayes-Lattin accepted our invitation to return. He always has one of the most popular talks, and it really appeals to providers across the age range, both medical oncology, pediatric oncology, surgical oncology, and radiation oncology, also extending into our other fields. I have a formal introduction for Dr. Hayes-Lattin, which is definitely not his style, but I'll give a little bit of the formal and then the more informal. So first, Dr. Hayes-Lattin is a friend and a wonderful, wonderful AYA oncologist. Formally, so he is a professor of medicine and deputy division head in the Division of Hematology and Medical Oncology at Oregon Health and Science University. He's also the director of the OHSU Knight Cancer Institute AYA program. Informally, Brandon's been a leader in AYA oncology for years and years. I won't say decades because I think that would age some of us, but yeah, I mean, Brandon's been really instrumental in AYA efforts and campaigns dating back to Live Strong, Critical Mass, and really all national AYA efforts Brandon has had an important impact on. In terms of our field and where we're going, Brandon's role both in his current institution as well as nationally is really important in terms of not just the challenges and struggles we've had as a community, also what resources and what impact we need to have moving forward to fill those gaps. So on that note, I will say thank you, Dr. Hayes-Lattin, for joining us. I'm going to pass it over to you for what will be an exciting talk.
Well, thank you very much, Mike. That's very generous. And thanks, Nick, and everyone else associated with AYA Power for inviting me back, I guess. As I was saying before folks logged on, I'm relatively new to Zoom because my institution doesn't ever use it. So let me just make sure I get my slides up and running.
Perfect.
That look good? All right. Yeah, so thanks. I'm going to spend maybe 30 minutes or so kind of reviewing the changing epidemiology in AYA cancer. And part of this kind of reflects the, what was described as the theme for this season, which is that we want to look ahead at not just in the past of how we got here, but look ahead in terms of what we can do. And really, from my perspective, the field of AYA oncology was really initially grounded by a bunch of observations in epidemiology. And I'm going to kind of touch bases a little bit on the history of that. But spend most of the session actually reviewing some of the new changes in epidemiology that hopefully will lead to new questions, new hypotheses, new research, new care delivery systems for AYA cancer. So that leads me to the objectives. Understand the ways in which epidemiology of AYA cancers, both incidence and outcomes, differ from younger and older cohorts, and how that's changed over time. And then using these trends to generate hypotheses to explain differences. And I'm going to focus specifically on biologic hypotheses, knowing that many of the future talks in this season will cover a lot of the other relevant topics. So I will show how some of these examples in epidemiology correlate with what we think is unique biology of AYA cancers. And I have no disclosures that are relevant to this talk. So I am going to start with a few slides of the history of AYA. Many of you who joined this series already are aware. But if we go back in time and think about the epidemiology, really, it was decades ago. There were epidemiologic trends that led to the field of AYA oncology. And just a couple of quick examples. This was an analysis done years ago looking at the 5-year relative survival rate by year of diagnosis. So if you were diagnosed with cancer in 1975, 1980, 1985, et cetera. And the different bars show the age at diagnosis. So if we start on the left part of the graph, what you see is if you were diagnosed with cancer between the ages of 5 and 9, in 1975, you can see the 5-year survival rate was roughly 55%. And you can see that each 5-year increment, 1980, 1985, et cetera, we were making improvements. And the 5-year relative survival rate went up and up at the time of this slide. So for an analysis done in 2006, 20 years ago, the 5-year survival for these children was 80%. If you look on the right side, for older patients diagnosed with cancer, you can see that while the absolute survival rate, relative survival rate is lower, each 5-year increment, we're getting better. The survival rate was increasing, going up from, roughly 40, 45% up to 60 plus. If you look in the middle, though, at our AYA age population, what you see is a couple things. One is that the relative survival rate was high. In fact, back in the 70s and 80s, it was the highest, but it stalled out. And there was really no improvement in relative survival over the course of these 25 or 30 years. So that was one of the highlights that led to focusing on this age population. And another way of looking at it is this famous or infamous graph looking at the average annual percentage change in survival, which shows this gap, shows that for younger patients and older patients, every year there was a positive in green increase in survival, annual percentage change of 1 to 2%, whereas in the 15 to 39-year-olds, it was significantly lower. And really that, along with a whole bunch of the context and psychosocial issues around this patient population, but specifically this epidemiology and survival data led to this big report, led in part by the National Cancer Institute, that established the field of AYA oncology with this wide age range of 15 to 39. But the reason for that, the reason that we consider that our AYA age range in the United States is really because of these epidemiological trends. And when we see gaps, when we see challenges like this in the epidemiologic data, it leads us to generate hypotheses. Why would there be these gaps for adolescents and young adults? And over the last 20 years, many of you have been interested in, and many of us have been looking into a variety of these hypotheses. One, do patients in this age range get different kinds of cancer? Or if they have the quote unquote same type of cancer as younger or older people, is the biology of their cancer different? And that's part of what I'm going to focus on today. In addition, the age of the patient themselves may have different biology, different metabolism than younger or older patients. And then there's a whole bunch of other hypotheses that I'm not going to cover today, but are the focus of this series of different ways of treating cancer, different access to care and treatment settings, differences in supportive care of all types, et cetera, et cetera. So I'll start by saying it is true that there are unique subset of cancers that occur in patients aged 15 to 39. And this sort of gives you a snapshot of if you're going to get cancer in this age range, what are the quote unquote common types? And you can see that these are not the most common types across the board. Most common types of cancer across the board in older patients would be lung cancer, prostate cancer, breast cancer, and colorectal cancer. You see some of those starting on to show up on this list, but for males, age 15 to 39, the most common cancer is actually germ cell tumor or testicular cancer. You see in both males and females heme malignancies like leukemias and lymphomas. You see melanomas and brain tumors and sarcomas, and things that are otherwise relatively rare cancers turn out to be the common cancers. And again, this is a big age range. So if you look at patients diagnosed between 15 and 39 in this graph, what you see is the different colors represent different types of cancer. So you see a different mix based on, is the patient in the 15 to 19-year-old age range or the 30 to 34-year-old age range. But again, if you correlate some of these colors, what you see is that the carcinomas, which are the most common cancers, are relatively rare, particularly under age 25, and do become more common in the AYA age range. But instead, you also see these things in green, which are brain tumors, heme malignancies, and other tumors like that. So that kind of gives you just a quick snapshot of what we mean by epidemiology and what sort of epidemiologic trends led to really the establishment of the field. So I'm going to pivot a little bit now and talk about some of the new or updated epidemiologic trends and speculate a little bit about, well, if we're seeing changes or differences there, why? What kind of hypotheses might we start to generate? And again, as I said, I'll focus a little bit on biologic hypotheses. So I'll start with this journal, the New York Times, which recently published an article asking why are more young people getting cancer? And in this particular article, they focused on the increase over the last decade of a lot of types of cancer that have increased in incidence in people under 50. And again, the age range of what's young and what's not young can vary based on how you're analyzing it. So for instance, there is now sort of a growing trend of looking at what's called early onset cancers. So things like early onset colorectal cancer, where early might mean under age 55. But generally speaking, it does point to patients who are getting cancers younger than we would expect. And clearly that overlaps with the age range that we call AYA. So when the New York Times is running an article like this, what is this about? Well, I think largely it's data like this. This is an epidemiologic analysis looking at the number of cases of various kinds of cancer that were observed in the United States compared to what would be expected based on historical trends. So if you start on the left-hand side, at the top you see female breast cancer. Again, this data is up to age 50, but in the 15 to 49-year-old age range, you see in the gray, female breast cancer, expect roughly 42,000 cases, but instead in the black, what was observed is more than that, upwards of 45,000 cases. Or if you go to the graph on the right, the excess number, the number of observed cases more than you would expect of female breast cancer, is pushing 4,500, almost 5,000 cases. So if you go down the list, you can see that that's true for colorectal cancer, kidney cancer, uterine cancer, pancreas cancer, et cetera, to different degrees. And so this is the kind of epidemiological trend that is raising a lot of questions. It seems that there's more diagnoses of cancer, and why would that be? I'll show you a couple of other examples of looking at this trend. So I open by showing that curve of what's called average annual percentage change. So the average percentage change, or APC, is listed here for global, so this is not just the United States, but global trends in cancer among females between 1990 and 2021. And what you can see is this graph has been clearly going up. This is looking at the number of cases per 100,000 in a population. And you can see that the absolute number has gone up. But if you look at the fine print of average annual percentage change between 2014 and 2017, that average annual percentage change increase in cases was 1.4. And just in the last 4-year cohort they looked at, it was still going up with an average, annual percentage change of 0.57. This is a focus more specifically on GI cancers during that during that time frame. And again, this is global, but you can see that while there was actually a reduction in the incidence of GI cancers in the early 2000s, that trend has changed course and now is increasing. And specifically in the 4 years between 2016 in 2019, that average percentage change was up 2.6. So these are the sorts of things that that have led to this analysis of, hey, there's more cancer happening in younger patients. What we're looking at here is the incidence. It's the rate per population. But in addition to the rate per population going up as the population grows and patients live with cancer, there's another graph called the prevalence. So the prevalence is how many people are alive with this diagnosis, with this disease. And you can see the prevalence of GI cancers in the terms of global trends has gone up and up and up. So why might this be the case? There's all sorts of potential speculation, hypotheses, looks. And I'm just going to really quickly run through some examples of what's been out there. Sometimes people forget to think that a second cancer after having a prior cancer can be a cause, but actually second cancers are not an insignificant proportion of cancers among young adults or young adults who have cancer and get cancer later in life. So this just shows the rate of breast cancer among patients who've already had breast cancer in the dark graph versus matched controls who've never had breast cancer. And you can see there's a dramatic increase in breast cancer among breast cancer survivors. However, among breast cancer survivors, there's also a significant increase in other non-breast cancers like ovarian cancer and melanoma. So just in and of itself, if there's an increased number of breast cancer and breast cancer, having cancer is a setup for secondary malignancies, that can help explain some of this trend. But there have been a lot of other hypotheses. In fact, if you look at that New York Times article or many of the other lay press, there's a lot of preliminary epidemiologic investigation about why might there be more cases of young adult cancer. Could it be rates of smoking? Rates of smoking have gone down for males, but actually have been fairly steady for females. Could it be alcohol use? And this particular graph is looking at early start of alcohol use. And that continues to be fairly prevalent across the United States. There's a lot of consideration about obesity or overweight status. And you can see that in some populations, the prevalence of being overweight has increased over the last 20 years. Physical inactivity as a potential correlate to that. Talk about diet. This is not a huge change in the amount of fruits and vegetables, but overall pretty low amount of fruits and vegetables, so speculation about that. And on the inverse, other protein sources, and you can see there's been a lot of talk about things like cold cuts or processed meats, etc. So I'm just giving these examples of what's been out there, what's being discussed, what is beginning to have an examination based on epidemiologic trends. And if we see signals there, that leads to more detailed analysis. Here's another one that I thought was a little bit controversial or intriguing, which was looking at the relative risk of cancer related to various forms of female birth control, with sort of the oral contraceptive pill, the bottom line in this chart being the baseline, and some longer term and injectable forms and how they compare. And what you see is the things in green are statistically significant decreased risk of cancer. So for really all of these things like endometrial cancer and ovarian cancer, use of contraception actually reduces your rate. But for many others, like breast cancer, colorectal cancer, melanoma, thyroid, there's actually a statistical increase in cancer risk associated with these, and there can be difference in different products that are used. Finally, as a word of caution, these epidemiologic trends have to be thought of in context. So recently there was a publication in JAMA Internal Medicine where the subtitle of the article was, "Could this be more apparent than real?" This is looking at the increase in cancer diagnoses. So if you look at the diagnoses in the blue, you can see that for thyroid, melanoma, breast, colorectal, kidney, prostate, etc., those are above the line. There's an increase, there's an excess diagnosis compared to what would be expected. So that's this, more cancers in young people. However, if you look at the orange color, which is the deaths related to those cancers, you actually see in many of those cases, the deaths are stable or even down. The concept here is perhaps there's overdiagnosis, or another way of thinking about it would be maybe there really is an increased diagnosis of meaningful cancers, but our therapies are getting better, which is important because you might argue more apparent than real. It's pretty real if you are diagnosed with cancer and get treatment and just do well. So just to sort of point out that when you look at the epidemiology, there's a lot of ways to dig into it. For sure, there's an epidemiologic trend of an increase in young adult cancers, but why and how that manifests in terms of actual death rates is some of the data I'm presenting. So for the rest of the talk, I'm going to switch gears and I'm going to talk about some individual cancers and just sort of tie a little bit of the epidemiological observations with some of the biological discoveries that show that we're really dealing with unique set of cancers and unique patients. So I'll start with testicular cancer. In testicular cancer, this is primarily a disorder called germ cell tumors. So you can get other tumors in the testicle, but usually when people talk about testicular cancer, they're referring specifically to germ cell tumors. But it turns out that germ cell tumors don't have to start in the testicle. Occasionally, they also start in the chest, in the mediastinum. And this is a bit of a complicated slide, but what it's showing is 3 different genes, KIT, RAS, and TP53. And what you see is there's a very different rate of these kinds of mutations based on what's called TGCT, testicular germ cell tumors, versus MGCT, or mediastinal germ cell tumors. So if you look just at that bottom line of TP53, which is a troublesome gene known in oncology that's associated with more difficulty to treat and worse outcomes, the rate of TP53 mutations in mediastinal germ cell tumors is significantly higher than testicular germ cell tumors, and that correlates with worse survival outcomes for that group. Switch gears a little bit to melanoma. Melanoma is unfortunately one of the more common cancers among young adults, but it behaves differently in young adults as well. This is one of the old epidemiological data that still holds true, that shows that for older patients who get melanoma, it's more associated with being located in the head or neck, which is the sites of long-term sun exposure, as you might expect from the pathophysiology we think of for this. But in young people, if they get melanoma, it's actually more common that it occurs in the trunk, which is not necessarily the primary site of prolonged sun exposure. So suggesting that there may be differences in the biology of melanoma in young people. And we now have more data that is based on that epidemiologic trend, showing that there's biological reasons for that. So compared to older patients, younger patients with melanoma have different frequencies of certain mutations, either increased frequencies of BRAF and PTEN or fewer mutations in NRAS. And they have a higher proportion of abnormalities that are not associated with ultraviolet radiation related mutations, which would explain that epidemiologic trend that I was just showing. In breast cancer, many folks know that there are different subtypes of breast cancer, including ones that are hormone receptor, like estrogen or progesterone receptor positive or negative, and also a mutation in a gene called HER2 that can be positive or negative. It turns out that the components of breast cancer in these characteristics, they really vary at the age of diagnosis, with younger patients more likely having hormone receptor negative and HER2 negative basal cell component tumors, whereas older patients more likely to have hormone receptor positive and luminal tissue cancers. Well, as we go through some of these biological some of these epidemiologic observations and we dig into the biology, here in breast cancer, what we see is if you look at the AYA group compared to older perimenopausal, menopausal, or even older patients, there are certain genes where the red, the AYA group, really stands out as having statistically significant increase mutations in certain genes, even among patients who otherwise have the same tissue type. So these are all estrogen receptor positive, HER2 negative breast cancers, but you can see that that there are genes in GATA3, in HERK2, and others where the red, the AYA group, has a significantly increased proportion of abnormal mutations. What do we know about colorectal cancer? Again, that's been identified as one of these epidemiologic trends with increasing rates of cancer. And what we see here is compared to older adults, if you look at samples from adolescent and young adult patients, you see a significantly increased likelihood of having a mutation in cancer syndromes. So there's a syndrome that predisposes patients to cancer, including colorectal cancer, called Lynch syndrome, that is associated with a MSH gene. And you can see for MSH2 AYA samples, there was a 38% chance of having a mutation there, whereas in the general population of older patients, it's only 3%. And you can see that that holds true for other mutations as well. In addition to that, there have been these epidemiological trends have led to other hypotheses of could this be related to other factors? I mentioned before questions about energy balance, weight, and metabolism. And here's just an example from a few years ago looking at a dietary insulin load and showing that based on a patient's ability to metabolize sugar and how that affects insulin load, if you break that metabolism down in 5 different quartiles, you can see a significant change in disease-free and overall survival based on that insulin response. Couple more examples. This is brain tumors. And this is looking again at 2 different types of brain tumors, one called glioma and one called medulloblastoma. And the graph is looking at age of diagnosis over time. And while the genes are maybe not so important to many in the audience, what you see is that the colors change based on the age, right? So in some of these genes, they're much more prevalent in younger patients with the same type of brain tumor, whereas that shifts and becomes less likely, and instead you see other colors, other genes mutated for older patients. Finally, I'll wrap up with leukemia, which was one of the hallmark diseases for these epidemiologic trends early in the course of creating the field of AYA. And again, busy slide, you don't need to look at the details. If you just look at the colors, what you see is individual genes have very different rates of color yellow for childhood cancer, for childhood ALL, dark black for AYA, or the blue for adult. And just as an example, I guess, 5th one over from the left says EVT6 RUNX1. You can see that's quite common in childhood cancer, but quite unusual in AYA and older adult cancer. And that is a good prognosis, a genetic abnormality in ALL. Whereas if you go to the other end of the spectrum, there's something, the third from the right is called PH-like or Philadelphia chromosome-like. That's a particular set of genomic of gene signature that looks like a classic Philadelphia chromosome ALL, but doesn't actually have that particular translocation. And you can see that is far and away the most common subtype in the AYA age range in dark, much more than in childhood yellow or even in adult blue. And that is a poor prognosis genetic feature in ALL. Finally, in ALL, this looks at other genes. So you can see Philly-like again is highlighted towards the bottom there. But you see other genes that are associated with good or poor prognosis and have a very different median age that they are observed or different incidence based on age. So that's sort of a whirlwind tour of epidemiology in AYA and new trends, including increasing diagnosis of certain subtypes of cancer in AYA, and how we use these epidemiologic trends to explore biological hypotheses. And with that, I'll say thank you and figure out how to pull my slides down, and happy to entertain thoughts and questions.
And thank you so much. That talk is really informative. I must say, I've heard you talk on the topic multiple times, and every time I learn several things that are new to me. We're now going to transition to questions. I'm going to pass it over to Scott to start to lead the Q&A session.
Well, thank you again. And for anybody, yes, you can put the questions in the chat or feel free to unmute. And if you feel comfortable, turn on your camera. So we had a few questions. One was you were talking about increasing in diagnosis rate, but specifically, can you talk more about how that relates to stage or grade of those diagnoses, and are there higher risk versus lower risk?
Yeah, it's a great question, great observation, really. So maybe part of the background is, for staging in various cancers, being diagnosed with more advanced stage is almost always associated with a poor prognosis. And we have known even for decades now that adolescents and young adults who are diagnosed with cancer tend to present with advanced stage. And that's true for multiple tumor types, including ones that more commonly occur in children, but also more commonly occur in adults. So for instance, in breast cancer, it's well described that that women under the age of 45 are more likely to present or be diagnosed with their breast cancer when they have spread to lymph nodes or they have distant metastatic disease. It also turns out that stage by stage, younger women with breast cancer do worse than older women with the same stage. So I didn't present any data about changes in that. You would hope that with more awareness of AYA cancer, people might present with earlier stage disease. But there hasn't been a lot of that seen in the literature yet. And part of that is some of the age-old concerns we have in adolescent young adult oncology, where patients and providers who see a patient with a medical concern don't necessarily think first or second or third of cancer as being a potential cause. So they're not necessarily diagnosed at earlier stage. And for the vast majority of the cancers we're talking about, there is no established role for screening tests for these cancers.
Thanks. And kind of along those lines, do you foresee an increase in utilization of genetic testing as a preventative tool in identifying cancer markers earlier? And I'll maybe take that a little bit further in thinking about the current climate and environment with insurance and approvals and prior auth. And what are your thoughts on that, and kind of where do you see that going?
Yeah. So I think that's going to change a lot. I think the role of genetic testing in cancer is one of the exciting developments, and there's lots of ways that I think that's going to change over time. One aspect of this is when a young adult gets cancer, particularly if they get cancers for which it's unusual, that often does trigger a genetic evaluation looking for the potential of familial syndromes. Obviously, patients who are diagnosed with young adult cancer are the sort of prime example of underlying biology where there are familial syndromes. And I think because there is more and more awareness of this, we are more appropriately sending people to genetic counseling to look for these things, and potentially save other family members the risk of being diagnosed with cancer or being diagnosed with advanced cancer. The second, which I think you're getting to a little bit, is when a patient is diagnosed with cancer, what is the role of doing deep genetic analysis to determine not just prognosis, but in many cases, actually differences in recommended therapy. There can be insurance coverage challenges with that, but I think this is a field that's changing quickly, and more and more we are able to do these analyses and target therapies based on that. Then I think the last thing, which is still relatively new but quite exciting, and many cancer researchers are working on is sort of the concept of early detection of cancer. Historically, cancer is detected by screening exams like a mammography, for example, or a pap smear for cervical cancer. But we are starting to see innovative ways of doing essentially blood tests, looking at circulating DNA that may be associated with a tumor that we wouldn't otherwise see. That is definitely not ready for prime time at all. And how that's going to roll out for older patients who are at higher risk of having these hidden cancers versus young patients, I think it's too early to say. But those are some of the things that people are thinking about and working on.
Yeah, thanks, Brendan. One comment regarding access to genetic counseling and testing. There's a really exciting new study that's coming out within our community practices looking at increasing access to remote genetic counseling and testing using a chatbot and kind of digital navigation. So acknowledging that many patients in certain communities do not have access to genetic counseling and testing resources. So I do think that will be a step in the right direction. A question for you regarding something that you opened your talk with was epidemiology and identifying trends and problematic trends is the start, but we need to act on those trends. And I was wondering if you could comment on what we're seeing in thyroid cancer, where clearly there's an increased detection of thyroid cancer. Many of these are low stage thyroid cancers. And there hasn't really been much of a shift in mortality, suggesting that perhaps we're picking up cancers that may not be that impactful in terms of survival outcomes. Acknowledging that thyroid surgery and thyroid treatment does have an impact on individuals, what do we do about this trend, or what are your thoughts on where we move forward with this type of cancer?
Yeah, really important observation. And I'll start by saying, I don't personally take care of thyroid cancer, so I'll caveat my comments a little bit with that. But yes, I think generally speaking, there's this balance of, are we, in some cases, and thyroid cancer may well be one, are we over-diagnosing cancer? Are we not only exposing people to the stress of having a cancer diagnosis, but exposing them to treatments like surgery that maybe they don't need and are impactful or toxic or otherwise. And there are other really concrete examples within cancer where this tension or controversy exists. Maybe another prime example would be in prostate cancer in older men. At the end of the day, many oncologists will argue, well, the most important feature is survival. Are you dying of this cancer or not? But I think each cancer, the approach to that is a little different for each cancer. So, for instance, in testicular cancer, which is a common young adult male cancer, the survival statistics are really good. Many people with that diagnosis will survive, but you still have to get there. And finding a testicular cancer early, the treatment and risk to the patient is significantly less than finding it at an advanced stage. So I think the sort of the approach to this does differ a lot, cancer by cancer. But I think many people are looking at the thyroid cancer example of, hey, there's probably a significant proportion of those diagnoses that are medically not important. Not only would they not threaten the life, but they're actually exposing people to excess risk.
Yeah, that's really helpful. And Stephen in the chat, put in the comment, this is the sort of watch and wait method, and potentially is that something we could do for some of these more indolent lesions. It looks like Betty is a bold soul and has her hand raised. Betty, if you're able to come off mute, that would be great.
Yeah, thanks, Mike. Brandon, that article from JAMA, The Rise in Early Onset Cancer in the US Population More Apparent Than Real, a lot of media outlets took that up and wrote commentary on it, right? When I first saw that, I was really frustrated, and I'm not a researcher, and a lot of this is over my head, but the way that the media, common media, was taking this was like, this is all farce. There isn't a higher incidence. And to me, this was related to number of deaths. And it actually angered me because survivors didn't seem to be in this equation. So please help me here.
Yeah, yeah. I mean, I think you're kind of looking at two different epidemiological things, right? Apples and oranges. So just say that theoretically there was a cancer for which we had 100% cure rate. You could have a significant increase in the number of those cancer diagnoses and the number of people who need the treatment. But because it's 100% curable, the death rate's not going to, is going to remain zero all the time. So both of those things can be true. You could be doing better with the death rate, but still have a really significant and meaningful, impactful increase in the cancer diagnosis.
I would love to see a commonplace article written with that explanation, because my brain read so many of them as poo-pooing the incidence in uptick.
Yeah, Betty, I'll add, so I was interviewed recently about kind of that topic in that article, and I gave my spin, well, you don't know what I said yet, but I gave my spin kind of both sides of there are definitely cancers that are increasing in incidence and mortality and are causing both survival and quality of life impacts. And those are cancers like Brandon shared, colorectal cancer, breast cancer, we're seeing that. And then there may be other cancers that are increasing in diagnosis and incidence, and our reaction to those cancers may be causing more harm than good. So what I had said in that interview over and over again is it's really nuanced, and it's not just a blanket statement. And I think for the public, we need to be clear about it. It's not that, this is a mirage, and it's, there are definitely cancers that are very serious and causing a lot of harm. And we also just have to think about our roles as providers of doing no harm. Brandon, we've got Betty, thanks for the great comment and question. Brandon, we've got a new series here for season 3 Power. I was going to kick it back over to Scott. So because we're capturing experts in the field, we want to ask a series of questions about where we go in uncertain times. So Scott, I'm going to pass it back over to you.
Yeah, thanks, Mike. So we're going to be asking all of our speakers this year these same questions to really kind of understand where we are, where we're going, and what we can do as a group, as a community, a network to help our patients going forward. So the first question is, which I think you touched upon throughout the talk, but if you can kind of summarize in your opinion, where do you see the field of AYA oncology going in the next 3 to 5 years?
One of the things that's kind of exciting to work in the field of AYA oncology, it's going lots of different directions all at once, which is really great. I think the focus of my talk today was in looking at these epidemiologic trends and figuring out where there are meaningful changes in the incidence and what it's telling us in terms of biology or otherwise. But I think that's only one. And I think I'm really excited for this whole AYA Power series because season, because there are lots of other trends in access to care and in care delivery, also in therapies. There are a lot of novel therapies and a lot of the cancers we're talking about. And historically, those have been launched in like advanced cancer patients who failed other things, but increasingly we're seeing earlier adoption of less toxic therapies. And since we're talking about a young adult cancer population, that's super appealing because, as I kind of alluded to, young adults are exposed to a whole long life of the potential consequences of the therapy. So as a concrete example, you could treat ALL, relapsed ALL, with months and months or years of chemotherapy or a one-time cellular therapy, and the long-term consequences can be very different. So I think there's all kinds of exciting directions of where the AYA field's going.
Thank you. And so what is one thing that we can do together as a community to help make real progress for AYAs now?
I have been engaged in this in decades. Thanks, Mike, for pointing that out. And we've made incredible progress, but there's a lot more progress to be made in just general awareness. So I think when we started, we had to define what AYA cancer was and kind of jump up and down and say this is an important population. And that seems less relevant now, but that doesn't mean that there are programs everywhere. That doesn't mean that everyone attacks AYA cancer in the way that that may be the most beneficial. And so I think there's still a lot of awareness. I'm encouraged by the fact that there are not only programs but funding mechanisms and things dedicated to AYA. But I think as a community, we need to continue to shout that this is a really special population at risk of being lost. You know, in biological studies and supportive care and psychosocial research and everything. And we should continue with that.
Absolutely. And a good transition. And I think kind of we're getting on this same path, but given today's challenges, what are some creative ideas or partnerships or interventions that can help us improve care?
Yeah. So again, I think one of the things that the field of AYA from inception has been really doing well and continues to do well, and this series of AYA Power demonstrates is bringing together a huge multidisciplinary group, right? So patients and patient advocates, researchers of all types, clinicians of all types, because together we definitely are more powerful. So I think that's one of the things that I've been super excited about and proud about this field, and I think that's the right direction.
Yeah, thanks, Brandon, so much. You're the perfect person to kick off this third season of Power, and you know, we can't thank you enough for your insight, your talk, and your decades of history and experience really helping improve care for AYAs. So we love to give folks a little bit of time back to their day. We want to, you know, share a couple more things as we end the first session of Power. I also want to acknowledge Nick, Kayla, and our partners at elephants&tea. You know, none of this could happen unless they had the infrastructure, dedication, and commitment to make sure this gets done and gets done well. So Nick and Kayla never ask for any thanks, but they really deserve a ton. It's been a wonderful partnership, and we also need to thank them because we want to continue the partnership for 10 more seasons. So on that note, what we'll do is, you know, we'll thank Brandon, thank Nick, thank the audience for coming. Nick, I'm going to pass it back over to you to help close us out.
Thanks, Mike. And I will laugh that the day you give us the nice thanks. I appreciate it. Kayla's not here. So we'll have to share that with her later, since for those that don't know, Kayla does about 99% of all the power stuff on the back end of things. So she's what makes it go. So thank you, Mike. Thank you, Scott. And Brandon, thank you today as well. Couple links that I just dropped into the chat for folks, the survey link. We send that out after each session. So if you're able to click on that and complete that, we appreciate it. We will email that out, if not today, on Monday. And then also to our next session is open registration, and that is on November 5th at 1 p.m. Eastern, adapting and advancing oncofertility care to enhance reproductive outcomes in AYA patients with Terry L. Woodward. So we are very excited for that next one. And we have a whole slew of sessions coming up. Our whole calendar is actually set for the season 3, I should say. I'll redrop our link there if those want to go take a look and see what's upcoming in December and January. Some amazing speakers, just like Brandon, that we are honored and thrilled that they are willing to be a part of this and this important initiative going forward. So again,
Nick,
Mike, go ahead. Scott?
Close out. Just wanted to add one other new initiative that we have started this year, which we're really excited about, is something called Power Direct. So for all of you out there that want to increase the amount of AYA education in your programs, your training programs, fellowship programs, please reach out to us, either to Nick, Kayla, myself, Mike, as we have developed a program where we, AYA Power, will come to you, directly to you into your training program to deliver education to your programs in a more intimate environment. So please reach out to us if anybody would be interested in that.
Thank you, Scott. All right, y'all. Have a great weekend. Great rest of your Friday. Brandon, thank you again. And everyone, take care.
Bye, everyone.